In this lecture, we are going to introduce a new type of layer, which has been shown to be very helpful in training convolutional neural networks. Here's something to consider. Recall that early on, we looked at why it's important to normalize your data before passing it into a model such as linear regression or logistic regression. We do this by subtracting the mean and dividing by the standard deviation. But because this is an operation on the data, we can only do it at the very first layer of the neural network. What happens if the data becomes not normalized at some later layer? Then that layer has to deal with unnormalized data, which is not as good as normalized data. So this begs the question, how can we make the data at every layer normalized? The answer is batch normalization. If you recall, inside the PyTorch training loop, we're actually doing batch gradient descent. On the outer loop, we loop through each epoch. And on the inner loop, we look at a chunk of data on each step and do gradient descent with respect to just this chunk of data. This works because we know that a batch of data will have approximately the same statistics as the full dataset. So what if we did something like this? We inject a layer that does normalization for us. For example, in an ANN, instead of dense, 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 we have batch norm dense, batch norm dense, batch norm dense. At each of these layers, all it does is take the batch of data, subtract its mean, and divide by its standard deviation. In fact, this is pretty much what batch normalization does. But there's something extra that batch normalization does. Here's another question to consider. How do we know that normalization is actually good? In fact, we don't. Perhaps there's a better amount of shifting and a better amount of scaling that we can use that leads to a more optimal model. And so this is the full description of the batch normalization layer. It first does normalization using the batch mean and the batch standard deviation. Then it rescales the data and reshifts the data so that the final output has an optimal location and an optimal scale. Of course, these new parameters, gamma and beta, are learned automatically using gradient descent. One alternative perspective on batch normalization is that it acts as a regularizer. As you know, we use regularization to prevent overfitting with methods such as dropout. So how does batch normalization do regularization? The idea is, because each batch of data is slightly different, it's going to have a different mean and standard deviation. It's not the true mean and standard deviation of the entire dataset. These differences are like noise, which slightly change what the neural network sees on each iteration. In other words, because the neural network always has to learn noisy images, it becomes impervious to the noise. The final thing I want to mention in this lecture is that while we discussed batch norm in the context of a feed-forward neural network, batch norm is not commonly applied in between dense layers. As you recall, this is the CNN section of the course. And so the reason we're talking about batch normalization now is because batch norm is mostly used with convolutions. Now, adding batch norm also adds some hyperparameter choices. In particular, you have to decide whether or not you should use batch norm. And if you decide you should, then you have to decide where to put it. Luckily, we can just follow the conventions in this regard. Batch norm layers are usually applied after convolution layers. Well, after or before depends on which way you look at it, so maybe a better way of looking at it is that they go in between convolution layers. One common pattern would be like this: convolution to batch norm, to convolution to batch norm, back to convolution, back to batch norm, and then flatten, and then your dense layers. So that's just to give you an idea of what it might look like. You're always encouraged to try things on your own, but also to read about the most popular CNNs, such as VGG, ResNet, and Inception, to see how they're doing things. This is the approach we're going to take in the next lecture when we improve our CFAR10 results. By the way, if you want to read more about batch norm, you can check out the paper included in extrareading.txt. The title is Batch Normalization: Accelerating Deep Network Training by Reducing Internal Covariate Shift.